Welcome to this edition of The Technology Pill, a podcast that looks at how technology is reshaping our lives every day and exploring the different ways that governments and companies use tech to increase their power. My name is Gus Hossain, and I'm the Executive Director of Privacy International.
My name's Caitlin Bishop, and I'm Privacy International's Campaigns Officer.
In this edition, we're following from our last podcast on diet ads. We thought we'd dive more into what we call the DIE, which we're releasing today, discussing what it is, what we've used it for, and how hard tech research is to get it right. And so today, we are joined by Chris Weatherhead, our senior technologist. Chris, why are we talking about DIEs?
So DIE stands for Data Interception Environment, which is because the tool we've created allows you to intercept data between secure systems, so you can analyze what kind of communication is taking place. We've used it for a number of different projects over the years, including looking at how that looks at things like how apps send data to Facebook without consent. And we've more recently used it to look at how menstruation apps send data to third parties.
Well, there's a problem to start with, which is I've been calling it the dynamic interception environment, not the data interception environment. So I already have learned something.
It's a double DIE, so it's a dynamic data interception environment.
That is technically true. So there's two types of analysis. There's static analysis and dynamic analysis, where static analysis is you take the app, you decompile the code, and you try and work out what the code does. Whereas dynamic analysis, which is what the data interception environment does, is you look at the network communication the app is actually doing and see what kind of data is being exchanged. And they both have different reasons why you'd want to do them. Like the static one, you can do in bulk because you can bulk get apps and you can bulk search apps for specific strings or data you're looking for. Whereas the data interception environment, you don't necessarily know what the remote third party is going to do. So you might see that data gets sent from the app to a server, but you don't know what the response from the server is necessarily going to be. So the data interception environment allows you to have a look at what the response is.
And so, Chris, just veering from that, what you've created allows an interested researcher, and I'm curious who that would be, just the level of sophistication required, to get beneath the hood, to see the data flowing out, whether it's from, I guess, starting from the web browser experience to the app experience and beyond, right?
Yeah, that's right. So the data interception environment can actually do all of those things. It can do just a straight web intercept, or all the way down to potentially IoT devices. It gets a little bit murky because the way that the interception environment works is it uses a certificate that you have control of, so that every request made from the device is signed by your certificate. The interception environment decrypts it and then sends the data on to the third party and does the opposite vice versa when data comes back.
Just what you're describing is the grand irony of increased security of the internet, is that data leaving your browser or data leaving your device often gets encrypted to the point where the average individual cannot see what's actually leaving because it's immediately encrypted to that sinkhole, to that third party, or to that website provider, or to that app provider. But what you're talking about is that you're doing true interception at the user level, which is the user, before that gets encrypted, the user can see what's about to get encrypted. Is that how it works?
Yeah, it's a little bit like it's actually more it's a true man in the middle rather than necessarily right at the user level. It doesn't necessarily have to be like immediately adjacent to the user. The environment is just a virtual machine. It can sit anywhere functionally. Obviously, when we're doing our analysis, we usually run it on the thing as close to where we're doing the interception as possible, both for legal reasons and generally because that's where it's easiest to analyze the data.
What you're describing is that within this VM, this virtual machine environment, rather than immediately having the data from the app or from the device or from the originating thing, rather than going immediately to outside and encrypted, you're allowing for a moment where that data is unencrypted, so and encrypted in the way that you want it to be encrypted, so that the researcher can pull out the data.
Yeah, exactly. You have two options when it comes to trying to read encrypted data. Either you get it right on the endpoint when it's been decrypted by one or both sides, or you have to try and somehow intercept and man in the middle of the communication. So the data interception environment does the man in the middle bit. There are other tools that do the localized looking at stuff. In fact, most browsers these days also have a way of looking at what data is being sent and received inside the browser. Like what we talk about a lot is, so you go to a website, you get asked about which cookies or third parties to communicate with. The browser's got quite a large feature set. So if you want to analyze what communications are taking place in the browser, there's usually the development tools and the network tab, and you can see from the network tab and the development tools, you can usually see all of the parties that are being communicated with and read the data that's being sent and received to them, which gives you quite a lot of insight, and it doesn't require any real special tooling. The problem starts to come, as you say, when you get towards phone apps, where you might get a pop-up when you open the app for the first time saying, do you consent? And you're like, oh, well, I just want to use your app. I don't really have the chance to read your privacy policy, or I don't, usually they're very binary. There's not a selection of trackers or people you can select which cookies you do and don't want to send. Usually it's either you agree to the terms or you can't use the app. And you can't see that data unless you do some really low level hacking of your device effectively to read that data. It's very hard to see from a normal consumer device. And then as we were talking about a little bit, but like when it gets down to things like IoT, there's almost nothing. Like an IoT device, you plug it in and it does magic effectively. You can't see, if you plug in an Alexa, you don't even necessarily get past anything. You just plug in an Alexa, you set it up using the app, and then it's doing stuff in the corner of your room. It somehow knows how to turn your lights on. It somehow knows, how to turn on the TV and your Ring doorbell, answer your Ring doorbell. And there's reading that data is very challenging. Like you need to somehow intercept it to be able to see that data.
And hence the DDIE, or the DIE, that is the interception environment to allow all these things to happen. So what, you didn't do create this environment just because you were bored. Maybe you are bored, but what have we used it for? What was the purpose? If as you say, a web browser today is much more capable of capturing the web activity, what is the value of having spent so much time developing this?
So yeah, we started developing this way back in about 2018, I think. So in 2018, GDPR was just coming into effect, and we were looking at various privacy policies across numerous companies and their apps. And we were like, how do we actually know whether the things that they say in their privacy policies actually ring true of the apps that they are distributing? So the key one we were actually concerned about was Facebook and profiling, how Facebook knows which apps or knows stuff about you, particularly around your app usage, and how it builds profiles around that information and how it feeds back into your social profile and other information they know about you. So we were like, how would we analyze the data that a third-party app, so in our case, we looked at things like Spotify, Skyscanner, Kayak, a whole bunch of apps across a large spectrum of different categories in the App Store.
There was even like a religious app category that you included.
Yeah, that we looked at a few Muslim prayer apps and Christian prayer apps. We looked at a few apps that were just utility apps, a few apps that you wouldn't even think needed to talk to the internet. So we looked at one that was just a flashlight, that was one of the most popular apps on the App Store, is just to turn the light on your phone to use it as a flashlight. And quite a lot of these apps, as soon as you open them after you've downloaded them, automatically send messages to Facebook before the users had any opportunity to consent, or at least that was the case in 2018. And the way we did that analysis was using the data interception environment, because as soon as you load the app onto a real phone, you intercept data as it's coming out of the phone, and you can see that as soon as you press the app icon on the screen, it starts sending and receiving data to all these other third parties, and then it's sometimes almost amusing to the point of ridiculous, where you get a message after it's sent a load of data to be like, do you consent to sending data to third parties? And you're like, yes. Yeah.
So it's like, I'll punch you in the face and then ask you afterwards, do you mind if I punch you in the face?
Exactly the same.
So in 2018, you did that, and good things happened when you were able to uncover this. You gave a talk at CCC, which is a big hacker conference, and people liked what they saw, particularly, I think, if I recall, around certificate pinning. The fact that you'd resolved an element of that was well greeted by the tech community. And so you got a favorable response out of that research, didn't you?
Yeah, so we, as I say, we had large swathes of categorized apps, and it was very interesting, the response we got from different companies, including some very large ones like Spotify, who were almost unaware of exactly how the integration of the code from Facebook, the SDK, worked within their own app ecosystem. I think both Spotify and Skyscanner were actually quite positive, their responses to us, being like, we didn't really understand that our app wasn't even complying with our own privacy policy because we'd never done the analysis of it. We just integrated the code that Facebook had given us and made no real further changes to that code.
Just for the listeners, I don't know if you've ever heard these small companies called Spotify and Skyscanner. This is insane, Chris. It is absolutely insane that you had to uncover this thing for large internet giants. I understand that another internet giant was, and I'm not going to use the language of taking advantage of them by stealing data, but I'll use the language of pilfering data from their apps and their user base.
And the process that these apps this is all happening through is through a tool within the code base of the app called the Facebook SDK that Facebook delivered or released for app developers, allowing app developers to integrate Facebook functionality. So if you ever use an app and it says, do you want to log in with Facebook? Or often when it says, do you want to share an activity? Or, if you're playing a game and it's like, do you want to share your high score on Facebook? Or do you want to check in with a location or a service? So you go to a concert venue or something, and they might have do you want to tell people you're now at the O2 Arena or something? I don't know, any concert venue. If there's some functionality with Facebook, it's normally these days now done through the Facebook SDK. But in addition to all those processes, it also adds metrics and analytics to the app. And the metrics and analytics are both for the app developers' benefit, in that they can switch them on, and then inside Facebook, they can monitor things like installs, monitor certain activities that they can prescribe. So just taking a random example, if you had a flashlight app, you could have it so that it reports back to Facebook every time the app is used and every time someone turns on or turns off their flashlight.
So Facebook would know everybody who's in the dark.
Yeah, so you might want those metrics if you're an app developer, either for just to try and show how much some part of your app is used, or whether you just want to try and improve your app, you might want to collect metrics on it. Or you might want those metrics for selling advertising to say, we have 30,000 users and they spend most of their time on the home screen. So if you want to put an advert here, you're going to have to pay us X. So that's all integrated in the Facebook SDK. And the Facebook SDK, at the time when we were doing the analysis in 2018, there was an update not long after the GDPR came into effect that supposedly made the Facebook SDK GDPR compliant. Although the functionality appeared at the time we were doing analysis to not work correctly. And it also appeared that a lot of apps don't regularly update the frameworks that their apps are actually using under the hood. So the current version of the SDK might be 1.24 or something, and then you'll pick up, you'll be doing an analysis of the app, and very handily the app tells you what version of the SDK it's running when you're doing a dynamic analysis of it, and it will tell you that the version it's running is like 1.16, so it's like 0.8 SDK versions behind whatever the current version is.
But a lot of people from my understanding was that the tracking came as switched on as default, and a lot of people just hadn't turned it off.
And not a lot of people, but a lot of developers, let's say.
Yeah.
It's the companies. Again, it's not the individual user who wasn't capable of doing this. They had no idea.
Yes, so the shipped version of the Facebook SDK, when you integrate it into your code base, the default behavior is that of what would be compliant in the US, because that is in Facebook's mind, I believe that's probably the primary market for them. And obviously, in America, there is no general data protection regulation. And then to add to that, a lot of apps are actually developed third party by someone else. So I'm a bank or a company, a taxi firm or someone, and I want an app because I think it's going to improve my business or it's going to improve my customer relationship, whatever. And I will contract that app to a third party that specializes in developing apps. And what you find is that the company that specializes in developing apps has a workflow that they just apply to all apps they're about to develop, regardless of what the actual app purpose is. They'll use this workflow. The workflow will include things like Google Analytics and Facebook SDK and Firebase Analytics, which is another Google service for monitoring things like crashes of an app. And they'll just integrate all of these things, regardless of whether they're actually going to be used in the app, because it's part of their development workflow. And if they implement at the time, at least, if they implemented the Facebook SDK without making any changes to any of its configuration, it would be compliant with the US understanding of data protection, if that's the right word, but it wouldn't be GDPR compliant. And in Facebook's documentation about implementing the SDK, they state that it's up to the developer to track local data protection law, which we find is not great advice, because although we've talked a lot about companies that develop apps, sometimes an app might just be developed by a one man or one person team, and that one person team has to do the software development, which they're probably very good at, but now has to understand the legal ramifications of the tools and services they're implementing into the app. Like PI has a number of lawyers, and it's sometimes a little bit hard to work out exactly what data protection procedure we're supposed to do for some category of data. How a small individual who's just developing ad hoc apps is supposed to know how their app is supposed to behave in Germany versus how it's supposed to behave in India versus how it's supposed to behave in other places, that Kenya with other data protection regulations, unfathomable, really.
Unfathomable. And it's but you can understand, considering that Facebook's such a small company, that it would want to shift the burden out to other small companies. Yeah, it kind of blows my mind. And this is the problem with app and app stores generally. You want somebody to be making conscientious decisions, because you can't leave it to a small company that outsources to an even smaller company to develop an app to all of a sudden understand what version of code is being used as given to them by Facebook, which, this giant. And so, and now since that 2018 work, Facebook did say it was going to do things and all that, but then Apple stepped up and said, we're going to make sure that apps in our app store declare what's going on. But still, even though there might be a declaration, you need to verify. And this is what your environment continues to allow us to do, which is to verify.
Yeah, exactly. It's all about verifying what is actually happening versus what's written in the text around the app. And yeah, just to finalize on the previous point about if some of these apps had very scant privacy policies. There was one app that had a privacy policy that was 3 paragraphs. It was all directed at Californian law, and it was compliant with Californian law, and that was it, even though it had about 10 million downloads. So I can't believe that all of those were in California. Anyway, so other research we've also done coming forward, I think to 2019, maybe 2020, we did work around menstruation apps and other apps that are used for tracking period cycles. Obviously, these are very sensitive apps in the sense that the data they're collecting is health data predominantly. And the interest there was to see what information they were sharing with third parties. So not just Facebook, but just other third parties that existed.
And they were sharing a lot.
Yeah, some apps are really good, and some apps are less so. And it's not just this is a dual problem, because it's not just the sharing of the interaction data necessarily, like whether the app was opened, how many people viewed X screen or went through X message or whatever the thing is. There's also a level of freeform in some of these apps where you can put in your own information about your period cycle, how heavy it is.
One asked you to write a diary, right?
Yeah.
One asked you to keep a diary and was asking questions like, when did you most recently masturbate? And then was sending all that information plain text, so not encrypted, to third parties.
Yeah, so some of this was very sensitive personal information, not just things like, when did you last have sex, but also things like what contraceptives are you on, what other medication are you taking. All of this is a special category of data under things like GDPR, which means it needs enhanced level of consent to actually process that data. And almost none of these apps ask for any additional consent beyond the base level of, do you consent with our terms? Do you consent with the general permissions of the app? So the basis of that research in that sense was to see which third parties and who they were, and then question those third parties about the processing of that data, both the first party in the sense of the app developer who implemented the code, along with the third party who's now processing data, many of whom are unaware that they're actually processing data outside of their own legal framework.
That's what Facebook said, right? Like, we didn't realize people were sending us this data and we don't want it. Was that the menstruation research?
To be clear, that's what legal Facebook said. I'm sure that somebody else in Facebook was noticing and enjoying it. It reminds me, I'm not accusing Facebook of lying because we engaged with them in good faith, but it does remind me of when Google was using Street View cars to collect Wi-Fi data. And, the Google legal team said, oh, we never signed off on this, but somebody signed off on it because the data was being collected and it was going to be used. So it is, it's one tentacle of a giant beast, not knowing what the other tentacle is doing. But it's lo and behold, these companies have vast amounts of data and can do much with it. I wonder how they get this data. And I wonder if their legal teams know that. But I'm not accusing them, because our legal team would get angry at me for saying stuff like that.
Going back to the previous thing about Facebook, the change they actually made in January after our research was to add 2 additional flags to the SDK's configuration file for explicitly setting consent after an action in the app. So before that, it'd been kind of almost a custom workflow, whereas now there was an option which a developer could just switch on, which definitely made it much easier. It would have affected about 2 billion or so installs of various apps, which is incredible amount of impact for what was quite a small amount of research, relatively, all done with the data interception environment.
But the thing with the data interception environment that I think both sets of research, particularly menstruation research, make clear is that the data interception environment can tell you what's being sent off the app and to where, but it can't tell you what the third party is doing with that data. For obvious reasons, that's not how it works. But yeah, it can tell you that X is being sent to Y, but it can't tell you if Y sends that data on to other people. It can't tell you, if Y is then processing that data in, some other way. It can't tell you. It can take the chain so far, and then after that, like you have to then go to the company, which is what we did with the menstruation research, because the next step was a ton of DSARs to those companies to see what they were doing with that data, right?
Yeah, we sent them these are data subject access requests that are allowed under the General Data Protection Regulation. And because you can ask questions like what categories of data are stored, who is that data shared with, that kind of stuff, and see if you've used their product or service, then they have to disclose these things by law. So you get an insight into how it's being held on the other side, the data you're actually giving. And the interception environment really helps with this as well, because a lot of this data will be connected to IDs. Yeah, it's also very useful to have the data interception environment when you're doing a DSAR, because a lot of app services like to convert your data from any identifier that connects to you to an ID that they store internally, which they think they can't get back. They can't go, who was Chris, or what was date of birth X, or whatever. They put it in some identifier which is then stuck in their database, and they refer to this as something like pseudo anonymization or something along that. Whereas the data interception environment allows you to see, in a lot of cases, what IDs, like global ID, they're using to store that information, be it using your advertising ID or some ID that they're using inside their system, so that when you're writing your DSAR, you can just be like, I'd like to know everything about ID X, which relates to me and is my personal data. Yeah, which is very handy as a part of a toolkit, I guess, for writing things like DSARs.
It's not just apps, right? Like the menstruation research is apps. The most popular apps all over the place in lots of different categories, including the Quran app and the Bible app, is apps, but you've used the DAI for more than apps.
So we've also used the environment in our work around low cost tech to look at phones that are very cheap, ultimately to see whether the phone is being subsidized by the data being collected from it, whether that's through advertising, malicious apps, adware, or other forms of channeling money, or making the phone more affordable by either exploiting the user or exploiting the user's trust to some extent. Some of the phones we've looked at, for example, we looked at a phone by my phone called the MY2, and that phone has an onboarding process that immediately starts when you first boot the phone up, that asks for a load of personal information, has no information about how it's going to process that personal information. All of that information is sent unencrypted. And the problem is that the phone is quite old. It was released in 2016, I think. And we were doing our analysis in around 2020. So that phone has all this information that it's sending out unencrypted. The problem there is that the remote server that this phone's supposed to be sending the information to, in theory would get a response from, is no longer available. And so the app, after you have to fill in this app unless you know ways around getting through the setup process. The app continually sends this information, I think it's every 300 seconds or so, to try and send it to the remote server, waiting for a confirmation that it's been received. So this means that as soon as you get on some like unsecured Wi-Fi or anywhere where the data can be read, you're basically giving out a load of information about yourself. So I think the questions include your name, your date of birth, the phone number you're using, your email address, a whole bunch of information. You're just sending it in the clear over the Wi-Fi you're using. Anyone can intercept and read that data, which is like terrible design. So that wasn't even before. That's before we even looked at the exploitation of the users themselves for monetary purposes. There's just bad security from the outset. This is also true of a phone we've done more recently, which is the Techno Y2 2018. Once you get into the phone, there's a whole plethora of apps and many of them you can't remove. They're like in the system partition on the phone, which is like where apps that are crucial for the phone's operation live. But these apps are all what I would refer to as value added services. So there'll be things like Facebook Lite, or often apps that are directly related to the phone manufacturer, or things that the phone provider is directly trying to sell as services, be them something like Triple Play, or which is where a provider serves phone, internet, and TV, or some other combination of services that the provider's trying to sell. Or they might just be random third-party apps, which there must be a business relationship between the manufacturer or the provider of the phone and these third parties. Possibly there's a payment going between the third party and the phone manufacturer to include these apps on their phone. So you can't remove these apps. Some of them run in the background, regardless of whether you need them, and some of them don't even exist in things like the App Store. So there's no way of really doing analysis outside of doing it on the actual device. And so that, again, the data interception environment is very useful in looking at exactly what these apps are doing, who they're sending data to, and an advantage of all of this, looking at the analyze the network. You could do this with other tools as well, but one of the advantages is you can get things like the IP address and the domain names being used by the app to send data. You can query who those belong to, whether they have any email addresses when you're trying to find out on from a data subject access request point of view, what third party, what data they're holding on you.
So it's useful.
Very useful.
So we've done all of this research and it's achieved quite a lot. Billions of people have benefited, whether they knew it or not, from the research.
From PI's research.
From PI's research. But we're releasing the DAI now because we think that it has value for other people, right? Oh, we've released it before. We're releasing this update and these how-tos and this documentation to make sure that other people who also want to do tech research can themselves benefit, right?
Yeah. So as you say, we've previously released a version of the DAI that we used originally for that Facebook app data research in 2018. What we're doing currently is releasing a much updated version that's got considerably updated tools. So there was some limitations on the original version of the data interception environment due to changes in technology over time and improvements in security generally. The original data interception environment could only intercept data between phones running Android 8.1 or lower, and it couldn't do iOS devices. The version we're releasing now can do both, which is a big improvement, especially with the iOS devices point of view, because we all of our work previously is targeted predominantly Android devices, which, although ubiquitous, are not the panacea of devices. On the benefits of tech research, I like to think that all the research PI does goes hand in hand, and they all support each other. So I like to think that if you're building a portfolio of research about a topic, you start off with your desk research, where you try and find out and locate who the actors are, how influential those actors are. You try and find out a bit about, maybe their corporate structures, the services they provide, who they talk to or whatever. And as part of that, you'll probably pick up, if you're doing, as we do, a lot of work around privacy, you'll pick up things like their terms of service and their privacy policy, at which point you'll probably need to consult someone with a legal background to ask, is this privacy policy applicable to the legal frameworks that exist in the places we're doing this research? And so they go and look at the privacy policy, and they say that, there's a few things in here that are of concern. There's paragraphs that we think aren't necessarily totally true, or that are, that don't necessarily comply with law. And without the tech research aspect, you're then stuck at a brick wall, because the only thing you can probably do at that point from a legal perspective is send a DSAR. You either have to try and use the product and service and then send a DSAR to see how the data is processed. And it's a little bit like you're missing out the middle ground of what data you actually sent them. And your recollection of the data you sent them is only necessarily the forms you fill in on a service or an app, which is where the tech research comes in, because the tech research, like using the data interception environment, allows you to then see exactly what you sent, how you sent it, keep a record of that information, that exchange, what data they sent back, because you might have sent data, they might not have received it, whereas you can confirm using the data interception environment that the data was received. This is like going back to the Facebook stuff. I think whenever Facebook receives a message from you, it responds with something like "okay" or "done," which is a nice indication that they definitely received what you sent them.
I mean, it also means going straight for the tech and how things actually work means you're not relying on what the company has said, because companies famously maybe aren't always as honest as we would like them to be. And if you go straight for how the system actually works, you don't have to rely on what the company's told you about how the system works.
The privacy policy might say we share data with 3 or 4 third parties, and then you fire up the app and it sends data to 7, and you're like, oh, so what about these 3 or 4 that you haven't mentioned in your privacy policy, and you're sending those data to those third parties? You get to that's the juicy bit. You're like, oh, I found something interesting here. Yeah, and that you wouldn't be able to do that really without some kind of technical analysis, which is why the technical analysis is valuable. The data interception environment, I've said before, is a virtual machine that runs in VirtualBox, which is a tool provided by Oracle. It's the entire software stack that it's running on is all open source software. It's running Debian as its operating system. And on top of that, it's running things like MITM Proxy, which is an open source project for manning in the middle HTTPS communications. It's also running APK MITM, another open source project for removing certificate pinning. It's got a number of scripts that me predominantly have written that is all GPL open source. And it, as I say, it'll do analysis of both virtual phones, which you can use. Like we use Genymotion, which isn't an open source project, but there are other open source Android projects you can use. Or it can do analysis of real phones running Android. The only caveat for running a real device, any real device, even if it's not a phone, if it's a IoT device, is you must be able to change the certificates that are installed. So on an Android phone, this usually means that the phone needs to be rootable or rooted. Don't go into much detail about exactly how to do that because it varies from phone to phone. Whereas if you do things with a virtual phone, a lot of them